Okay, rotation. A rotation is a transformation in which all points on the object are rotated through the same angle in the same direction about a fixed point called the center of rotation. All right, so here we can see that a rotation has three components. There is the direction of the rotation, there is the center of rotation, and there is the angle of rotation. All right, so a rotation has three components. It has it has to have a center, it must have a direction, and it must have an angle. All right, so in order for us to describe rotation, we need three things to describe it. Essentially, the direction of rotation could either be clockwise or anti-clockwise. So if your rotation is going in this direction, it is clockwise, and this is viewed as being negative, or it could be going in this direction, which is anti-clockwise, which is viewed as being positive. All right, some basic features about a rotation. Um, One, in the diagram, for the diagram, we can see that O is the center of rotation and that angle A, O, A prime, this angle here, angle A, O, A prime, this angle here is the angle of rotation, but that is the same as angle B, O, B prime. So it's the same as this angle here. So the angle AOA prime is the same as angle BOB prime, is the same as angle COC prime, and that is equal to the angle of rotation. So AOA prime or BOB prime or COC prime is the angle of rotation. Now in a rotation, each point on the object moves on the circumference of a circle to its a circumference moves on the circumference of a circle of its own radius about the center of rotation as center. So in a rotation, um, corresponding points on the object and image, um, or in a rotation, the points on the object moves on what the circumference of the same circle, or corresponding points on the object and image are on the circumference of the same circle. That's better. So in a rotation, corresponding points on the object and image are on the circumference of the same circle. So A and A prime are on the circumference of the same circle. B and B prime, they're on the circumference of the same circle. So in a rotation, corresponding points on the object and image are on what? The circumference of the same circle. What else? In a rotation, points points at the center of rotation are invariant. That is, under rotation, a point at the center of rotation does not move. Here's an example. All right, in the example, on the next page, we're to draw triangle A prime, B prime, C prime, the image of triangle ABC under an anti-clockwise rotation of 90 degrees about the origin. All right, actually, we're going to do much more than just that with this diagram. All right, so here I have triangle ABC, top left. I'm going to actually rotate it three times. First, always in an anti-clockwise direction. First, I'm going to rotate it. No, anti-clockwise direction is that direction. First, I'm going to rotate it 90 degrees. Some basic things about a 90-degree rotation. In a 90-degree rotation, horizontal lines become vertical and vertical lines become horizontal. Um, so first we're going to The center of rotation here is the origin. So it's 90-degree rotation, a rotation of 90 degrees about the origin. All right, essentially this is how it's going to be done. To get from the center to A, I have to go what? 2 units right and 1 unit up. If I rotate A 90 degrees, A, it's going to be, the new position is going to be what? 2 units vertical, 2, 1, 2 units vertical, and 1 unit horizontal. This will be the new position of A, that would be A prime. All right, so the line, the horizontal and vertical line from the center to A, the center is O to A, would be 2 horizontal, 1 vertical. When I rotate that, I'm going to get 2 vertical and 1 horizontal. All right, so 2 vertical and 1 horizontal. This would be the new position of A. All right, so my 2, 1 rotated, rotate this, it's going to become what? 2, 1 here. All right, so this would put the new position of A here. All right, so 2 vertical, 1 horizontal, new position of A. Here, this is A prime. From we're going to do a similar thing with C. From the center here, it's 4, 1, 4 horizontal, 1 vertical to C. If I rotate this, that direction, the horizontal 4 is going to become vertical 4, and the vertical 1 is going to become horizontal 1. And that will put my new position of C there. And put A down here. A prime. So 4, 1. This would be the new position of C. This would be C prime. And we're going to do a similar thing with B. This is 2, 4, 2, 4. If I rotate it, it's going to become 2 here, 2 vertical, 4 out there, 4. So it's 2 vertical, 4 out here. New position of B. This would be B prime. Use my ruler and connect. So what do I observe? AC was horizontal, and AC became was horizontal became vertical. So in a 90-degree rotation, horizontal lines become vertical and vertical lines become horizontal. All right, I can do the same thing again. So that is a 90-degree rotation. 2 horizontal, 1 vertical, new position of A. This would be A prime, A double prime. 4, 1. This would be C double prime, and 2, 4, new position of B. This would be B double prime. All right, connect them again. So now 2 vertical, 1 horizontal, 4 vertical, 1 horizontal. So this would be A triple prime, C triple prime, and 2, 4. This would be B triple prime. All right. So, what are some of the other things I've noticed? A, we started out with A being 2, 1, and when I reflected it, um, R rotated. This is R, O 90 degrees, it became A prime, which is minus 1, 2. All right, so what I notice here is that for a 90-degree rotation, um, the x and y coordinates interchange, means that they switch around, and the sign of the x coordinate change. So for a 180-degree rotation, A, which is 2, 1, so this is R, O, 180-degree rotation, became A double prime, which is A double prime is minus 2, minus 1. So whenever I rotate 180 degrees, the x and y coordinates remain in the same position, but their signs change. Now in a 270-degree rotation, A, which is 2, 1, becomes A triple prime, which is 1 minus 2. This is R, O, 270 degrees. So that's an anticlockwise rotation of 270 degrees about O, which is the origin. So in a 270-degree rotation about the origin, the x and y coordinates again interchange, but this time the sign of the y coordinate changes. So for a 90-degree and a 270-degree rotation about the origin, the x and y coordinates interchange. For a 90-degree rotation, the sign of the x coordinate changes. For the 270-degree rotation, the sign of the y coordinate changes. In a 180-degree rotation, the coordinates remain at the same place, but their signs change. All right, so the finished product was supposed to look something like this. So as you can see, our finished product looks exactly the way we have it. You can observe that A, A prime, A double prime, and A triple prime, they are on what? The circumference of the same circle. All right, so let's put some of that observation in words. These are some of the stuff I've said already. That in a 90-degree rotation, vertical lines become horizontal and horizontal lines become vertical. In an anticlockwise rotation of 90 degrees about the origin, the x and y coordinates interchange and the sign of the new x coordinate changes. In a 180 degrees rotation about the origin, the signs of the coordinate changes. In a 180-degree rotation, vertical lines remains vertical and horizontal lines remain horizontal. In an anticlockwise rotation of 270 degrees about the origin, the x and y coordinates interchange and the sign of the new y coordinates changes. In a 270-degree rotation, vertical lines become horizontal and horizontal lines become vertical.